we did thin film interference as a concept and kind of walked through it, I want to do an example. So maybe I have some water sitting on top of some glass. And we'll have a beam through air. This is going to be water and is 1.33. Glass will go 1.5. And air will go 1.0. We can give this thing a thickness of, let's go 500 nanometers. And what I would like to know is, for nearly vertical light, are there any constructive interferences that lead to visible light? So let's see what I've got. I've got this wave that comes in this way. Now I can look at this and I can say, well, I've got my middle N for my film layer, and I can just work with that and go straight to an equation. But just in case that's not super straightforward yet, let's go through the thinking. This is my phi equals 0 heads wave that refracts inside the water this way, and then refracts more inside the glass this way. Those are all heads waves because they are just refractions. So phi is 0 heads, phi is 0 heads. Alright, here I'm in 1.0, I'm bouncing off 1.33, so I am picking up an inversion. So that is a tails wave that's coming off of this. 180 degrees, or pi if you like, or it's a tails wave, whichever way we want to think about that. This one, I am in 1.3, bouncing off 1.5, so I am picking up an inversion here. So again, another tails wave. Phi equals 180 degrees, or pi, or it's a tails wave, however you want to think about that. And then we refract up, and same thing, it's still a purple wave. Still have my out of phase, my off phase, I guess, tails wave. And now I am interested in how these are behaving. These are currently in phase with each other. So I know that I have 2 times the thickness times the N of the film equals, and it's going to be, I'm looking for constructive interference. These are in phase already, so I want whole numbers of wavelengths. If I'm looking for, are there any constructive interferences with visible light, I need to know where visible light is. We generally take our visible light wavelengths to be somewhere in the 400 to 750 nanometer range. Now, I don't have a whole lot in this equation that I can actually mess around with. I'm going to solve for lambda, and the variable that I can really mess with is this j. So I'm going to make a quick table for myself. J and lambda. If j is 1, 2, 3, 4, 5, maybe I need to come up with some more of them, but we'll see. Either way, in this case, I'm going to get lambda equals 2 times the thickness times the N of the film. My film is water, so it's 1.33 divided by j. So I can plug in, I'm going to plug in one of them directly on here, and then I'm just going to give you the answers for the other ones. So for j equals 1, I'm saying my lambda is 2 times the thickness, 500, and I'm just going to leave that in nanometers because that's going to give me an answer in nanometers, times the end of the film, 1.33, which is unitless anyway, divided by 1. And when I do that, I get 1330 nanometers. N is unitless, 2 is unitless, and the J is unitless. So whatever units I use for my lambda, those are the units I'm going to get. For my thickness, whatever units I use for my thickness, those are the units of lambda that I'm going to get. I would love for my answer to come out in nanometers because I know that range in nanometers, but this is too big of a wavelength. So maybe I add a column for visible with a question mark. And the answer is no. So then I'm going to plug in my other numbers. And it looks like I don't have to do this. So I have, this one is visible, 665 puts me right in that range. 443 puts me in that range. 332.5, my numbers are going down, and that puts me at too low of a wavelength, so too high of a frequency, so that's not visible. So I get these two visible light rays, and they happen at 665 nanometers, which is pretty red, and 443 nanometers, which is kind of between yellow and orange. So I'll put yellow, orange. At a thickness of 500 nanometers for water sitting on top of glass, I will get two visible lights, visible light colors. One that's red, one that's yellow-orange. So that's the color that my water on the glass would appear. If I've got my block of glass like this, and I've got some water sitting on top of it, if that water is 500 nanometers, I'm going to see red, and I'm going to see like a yellow-orange. Maybe that's yellow-orange. That's what that'll look like. All I did was plug in different values for J and find which ones fell within the right range. But that's the whole process.